Okay, in this video I just want to take a few minutes and try to give you an overview of matter. So as chemists, we're going to talk a lot about matter, and in particular we're going to talk a lot about matter's interactions with other things and what makes up matter. And chemistry is the study of everything around us, and everything around us is made up out of matter. So it's worth it for us to spend a few minutes just giving you an overview. So when I say matter, a lot of people's mind will go to the three states of matter. And there's nothing wrong with that. Every time we interact with matter, we interact with it, and it is a solid, a liquid, or a gas. Some of those are really easy, right? Your solids are the thing, the table you're sitting at, the computer you're looking at. Liquids, the water you drink. Even the gas, the air you breathe is obviously matter. That's kind of the one that gets a little bit underblown, but matter is the stuff around us. And if we look more closely at matter, we'll see that it's actually broken up into two categories. So on the left here, we're going to talk about our pure substances. And then on the right, a little bit later in the video, we'll address our mixtures. So both of these categories you're going to see come up a lot in chemistry, but let's zero in on the pure substances first. The thing that defines a pure substance, it is consistent throughout. And you're actually going to see it's 100% consistent throughout. So what that means is that our pure substances, no matter what part you look at it, it looks the same as every other part. Now, truthfully, that's a nice little way of talking about it, but our pure substances are actually broken down into two categories themselves. Each of these following two categories are also pure substances. So we can have pure substances that are just straight elements, and we can have pure substances that are what are called compounds. So let's talk about each of these for a few minutes. Our elements are made up out of only one type of atom. And you're familiar with all of these, you just don't realize it. Examples here. A lot of people wear jewelry, and their jewelry is made out of maybe silver. Right, that's the elemental symbol, capital A, lowercase g, or maybe gold. That's the symbol, capital A, lowercase u. Kind of a more standard, common example is your coaxial cables, so your wiring in your house. That's made up out of copper. Elemental symbol, capital C, little u. All of these things are only one kind of atom. That's assuming that your jewelry is actually legitimate. If it's pure silver or pure gold, that's what it is. A lot of times those are actually mixtures, but the copper wiring, that's pretty consistent. A very household example, aluminum foil. Aluminum is Al, capital A, lowercase l. Right? You buy aluminum foil all the time and use it to help preserve your food and always have it in your kitchen. But notice all of these things are just one single type of atom. Kind of the opposite, or not the opposite of that, but a little different there, is our compounds. Our compounds are made up out of more than one type of atom. And the truth is, most of the things that you interact with are actually compounds, not pure elements, right? We see these things, but those examples, even though we use them, they're not that common. Much more common are our compounds that we see a lot. So if we want some examples of compounds, my favorite to talk about is water, H2O. Now, what's the H and what's the O? The H is representing atoms of the element hydrogen. The O is representing atoms of the element oxygen. Here's another example. We use table salt, which is NaCl. Right, this is table salt. Think about what this is here. This is actually two different atoms of two different elements, right? We've got sodium, Na, that's one element, and then chlorine, or Cl, is another element. So we've got two different kinds of atoms here. Our compounds are made up of more than one type of atom. I'll left that part off there. The thing that's important to remember, though, is that both of these things, both elements and compounds, are pure substances, right? Let's go back up and switch colors and circle that, because that's kind of an important thing to drop your mind back to. So both, any of these examples of elements or compounds are pure substances. That means that they are consistent throughout, right? Your copper wiring that runs through your house is copper straight through. Your water, your table salt, even though there are more than one type of atom, it's still consistent throughout, right? Get a big glass of water and drink it, and you're gonna see it's gonna be water the whole way through, unless there's some kind of thing that's in there that's not supposed to be. But if you get some nice purified water, it'll be H2O 100% of the way through. So like I said, we're gonna jump back over and talk about mixtures for a few minutes. What a mixture is, best way to think about mixture is in terms of a pure substance. If pure substance is something that is consistent throughout, a mixture is just simply not consistent. The trick to mixtures, though, is that sometimes they might look like they are. So our mixtures are things that are not consistent throughout, but we are actually going to have two types of mixtures that we're going to talk about here. We'll have what we call homogeneous and heterogeneous mixtures. And you have experience with both of these, similar to elements and compounds. So a homogeneous mixture, even though it is made up of different things, it's not 100% consistent all the way through the sample, it appears to be consistent. This makes a lot of sense when I give you an example. Go to the beach and run into the water, right? Go for a little swim, and if you ever get the water in your mouth, it tastes salty. That is because, what is it? It's salt water, right? So salt water is something that when you look at a bucket full of salt water, right? Scoop a bucket up into the ocean, you're gonna pull out a bucket full of salt water, and you look at it really closely, you can't see the salt and you can't see it separate from the water. It looks like it's the same thing all the way through. That makes it a homogeneous mixture. It's still inconsistent throughout. It's not the same stuff all the way throughout, right? We just said over here that water and salt are two different compounds. Salt water is just the combination of water and salt, but it appears as though it is consistent when it's not. That means it's a homogeneous mixture. And then our heterogeneous mixture is kind of the opposite of that. This doesn't appear to be consistent. This is obviously, that's not a very good U. There we go. Different. You can stay with our beach example here. Take your bucket of water, dump it out, and go back a few feet and scoop up some sand. Scoop up some sand, what are you going to find? Well, you're going to see some sand. You're also going to see probably some water. You're going to see some shells, maybe some seaweed, right? This is, even though your heterogeneous mixture is very obviously not 100% consistent all the way through, right? This is the quick version of your matter. This is kind of your overview. As chemists, we're going to kind of talk about all of these things. We'll work with some pure elements. If we work with a lot of pure substances, we'll work with elements, compounds, homogeneous mixtures, and heterogeneous mixtures. Hope this helped.